Okay, sorry. So I'm just gonna read for them. Okay. A question upper Nancy Taylor Hopkinson back-to-back test. The question goes here, it is the efficiencies of two identical shunt connected machines are determined using Hopkinson's back-to-back test. The following data with regards to the test is known. We know the supply voltage is 415. The current drawn from the supply is 11,7 amps. Then the generator armature current is 35. A motor field current is 0.8 amps. It's 0.8 amps. Then the generator output current is 34.1. The armature resistance of each machine is 0.5. Then they say draw the circuit diagram of a shunt connected machine clearly showing all the currents. Number 2, calculate the efficiency of the machine acting as a what? As a generator, while assuming the ion and what? Friction loss are what? Are equal. Okay, assuming ion and friction losses are equal. Okay, so guys, this question we said it can be asked in 2 ways. The question can say assuming efficiencies of both machines are what? Are equal. By CET question, assuming that the efficiencies of both machines are equal, so the efficiency is equals to what? 1 I1 over I1 plus what? I2. And the question in 2 marks, 3 marks. Yeah. Okay. This is what? Assuming that the efficiency of the generator and the efficiency of the motor is what? Equal. Simply use that formula. Okay. The other question in the marks is the one that we are assuming that the what? Ion and what? Friction loss are what? Are equal, which is the one that is being asked in this what? Question. So the first thing you do is you draw what? Circuit diagram and place your currents. So after we're going to have our voltage source, emitter value voltage 415 volts. Okay. Then armature motor okay. The current drawn from the supply money. Current drawn from the supply money. Where is my supply? This is my supply. So here is the current drawn from the supply man. Remember it's a shunt motor, so we put a shunt winding. What is the current that is flowing through the as you play current, you feel current in the way. If never go winding. Okay. Okay. So if the field current that I'm given here, you know, I'm going to solve the current is over P because take the motor's what? Field what? Current. Notice the direction of the current. Nah? Yeah. That is funny. Was 0,8 amps. Anna? Okay. Then we do generator. Nah? In terms of the generator, the shunt generator, I am given how much current, you know, generator, na? About 35. Remember, current is flowing away from the how much, and it was the generator. Okay, you know, the output what? You know, the current, and 34,1 amps. This is how we're labelling this. The current that draw from the supply is how much money? I2. And then?
Yes, sir.
The current that draw with generator money? And then? The current that flow, the load current here more to money? I1 plus I2. And then? Okay. The question is if we efficiency and on. The efficiency of the generator. Say balance and efficiency generator. CT is equals to by V. Ubano IL with generator. What is the load current or the output current in generator? Times 1 I1 over V times I1 plus how many losses?
3 losses.
Which are the armature copper loss and the field copper loss, and lastly the iron and what? The unit of electromagnetic depth is finding what? The iron and what? Friction what? We assume that the iron and friction loss are divided what? Equal. If 4 rand is divided equal between 2 people, 4 rand is divided equal between 2 people, each person will get a what? 2 rand. Let's say this person for X, no money, no Y. Okay, will get 2 rand. So it means that if value X is what? 4 over what? 2, which is the total amount. If value Y now money, 4 over what? So basically, what is the total what? Total ion and what? Friction loss. The total ion and what? So then we will have total C divided by 1. That means we will have that means to find the total. Then to get for each machine, we divide by what? To get the iron and friction loss for what? Each machine. Okay. How do we find the total iron and friction loss? Power in kule Hopkinson's back to back test is equal to what? Power out and plus how many losses in total? These 6, yes? Kukho intoni? Field copper loss, ne? Kukho ntoni? Amateur copper loss entoni? Yemoto. Then imoto iphinde ibe ne-iron and what? Friction loss. Same nakwi-generator, kukho ntoni? Field copper loss, amateur copper loss generator, iron and what?
Friction.
And friction loss. So we have a total of 6 what? Losses. Hence I'm gonna say is output power, input power is equal to output power plus what? 6 losses. Anna? Okay. But ke ngoku imbuzo uthi ke ngoku input power yale system ihamba njani? Input power is going to be V times what? I bani? I2, which is the current that is drawn from what? Supply. Yeah? The output power with Hopkinson's back-to-back test is what? No energy is consumed here. Energy is being transferred from the motor to the generator back to the what? To the motor, ne? Motor it drive a generator. The same air generator, air driver motor is the one that is supplying what? The motor. Hence the output is what? So out of this, I'm going to get the total of what? Of these what? 6 what? Losses. So it's about 4 what? 1, 5. The current run from the supply is to money? 11, 7.
34.1. Generator.
The current run from the supply money?
A generator.
Huh?
A generator.
So that's the current run from the supply.
19.7.
Hello guys, the input power input is coming from the supply. Don't use the current generator. The input is coming from here. This is what initiated this thing, yeah? So you're gonna use the one, the voltage, the supply times, current drawn from what? The supply. So that is why I'm saying 11, 7 is equals to 0 plus what? 6 what? Losses. Kubani, in total, Bani very, yes, losses, as is 6. What? The 10 combined. Kubani. 4, 8, 5,
5.
5.
4, 8, 5, 5.
4, 8, 5.
5.
Okay.
5.
5.
Yes.
And so, i-losses zam xa zipheleleyo naziya. Into ithi ke ngoku guys, xa ndifuna the total what? Copper. Sorry. Remember, sithe i-losses zingaphi? 6 what? Losses. And out of this, I want to take out the iron and what? Friction what? Loss. So basically it means game ngoku total iron and what? friction loss is equals to bani these 6 losses baziphelele ne ana okay minus the total what copper losses minus what the total. So this is where again what is over the table the body total copper losses zodwa then these are but those subtract kule total ndifumane ntoni total iron and what. So when I say draw a table, we have a motor here, we have a what generator upper. Okay. Now, okay. The copper loss of calidon, the field copper loss in your mountain. So, shunt copper loss your motor is gonna be field current your motor, then we don't shunt what? Resistance. Now shunt resistance. Shunt resistance. They pay a formula to use it on to find it on. An alternative formula is to say V times what? The field what? Current. Anna? Okay. Who V way to money? 415 na? Okay. Then shunt current to money? 0,8 na? So mbali ke moke shunt copper loss ye motor kapan 332 watts na. Okay, but strong moke non amateur copper loss ye non e generator na. Yo sorry motor sorry seven motor. Amateur copper loss motor is amateur current and made one resistance. Yeah, but yeah, amateur. Do we have amateur current motor? Do we? Let us go to our diagram again. Do we have the amateur current motor? No, eh? The amateur current motor is there up amateur, ne? Okay. But I can calculate it. How do I calculate it? I use Kirchhoff's what? No. The current here up I1. What is I1 plus I2? It's gonna be 34 34,1 plus 11,7. This one. What is that value? 45,8. Health and safety guys. Yeah, one. When you are writing, these are the things that will make you what? Make mistake because you are not focused. You tell me? You are no longer focused. About the question, if you now tell you, focus. It's normal, they don't fear. Fear is what? Normal to anyone. Nago Messi, Nago Ronaldo, even the Rap World Cup. Yeah. If you think on the match, you don't want to final one or you go police, but also you got but they know but you have to deliver, so they focused. Yeah. It's normal to fear, but don't lose your focus. Okay. Your future is resting in your shoulders. Simfumene loni le current yama phambane 45 bani 8. Ana? Because the reason I'm saying this, I know it's easy kasi class A, but when we get to the exam, we tend to have what? Fear, it's normal. So that means OIA bani, OIA motor is going to be this current, minus which one? That one, Then field what? Current. Remember, amateur current the motor is IL minus what? IL with nam, which is 45,8. The initial current answer 0,8. So that means amateur current into money 45 what? Then I can proceed and calculate the amateur copper loss, which is going to be 45 squared. Then amateur resistance money 0.1 5. Square. I see people the square. When you are using quite quick current, you must put in the square. Minus.
Ten,
12, now we are done with the values and let us go to the generator. Which generator? The shunt copper loss. We have the shunt current. So it's V shunt current. Do we have the shunt current generator? No. No, we don't have. Now you use Kirchhoff's what? Laws. Unayo current unayo current flowing towards the junction is equal to current flowing away from what? So shunt current ubani IA minus bani I bani 1. And which is gonna be bani 35 minus bani 34 bani 1. Bani shunt current generator, which is the current that is flowing here. 1.
0.9.
It's 0,9 amps. 0,9. So now we can find the shunt copper loss 415 times 0,9.
373.5.
373,5. Then we can find amateur copper loss generator, which is IA squared RA. What is the amateur current generator? 35, Okay, amateur current generator 35. So 35 squared, the resistance was 0.1. Find amateur resistance. But for both what? This is all money.
612.5.
For 6, 12, 5. So in other words, again, next is to find what? Let's say we're going to find the total what? Sorry, iron and what? And friction loss, by saying the 6 losses. The 6 losses were still such as 1 to 4,800 and what? And 55. And then thina into sizoyenza so subtractor zonke intoni copper losses from the total what? Losses, na? In order to get what? The total iron and what? And friction loss. So the total iron and what? And friction loss is over money. 4, 8, 5, 5, comma money? 5. Minus as losses zonke x. Minus as none? As copper losses zonke. So it's gonna be minus 332. And then minus 10, 12,5, 10, to 10, 12,5 minus into 373,5. 373,5 minus yokugqibela, and it is a 4. So 6, 12, 6, 12,5. Bani dot total iron and what? Friction loss rate. What answer am I getting? 2, 5, 2, 5. Kana.
Yes, sir.
That means get iron and friction loss till they are divided what? Equal. Ne? So this total amount is divided equally between the generator and the what? And the mode. So kanifuna for each, let's say ndifuna iron and what? And friction loss for each generator. I take the total amount and divide it by what? So it's gonna be 2, 5, 2, 5 divided by 2, 1. So 12, 62,5. I have found my third losses. I have found what? My third loss. Big question, if we efficiency generator, we said efficiency generator is equals to V I money I1, the load current or the output current of the generator over V I1 plus what? 3 losses. And so it's gonna be 415 times what? 34, comma 1, yeah? Divided by 415 times 34, comma 1. Copper losses, zingaphezulu loss, copper losses eziyi-2, shunt copper loss, amateur copper loss, then the friction, iron and friction loss. So now those losses are 2, and 3, 7, 3, 5, no money, no 12, no 6, 12, 6, 12, 5. So it's gonna be plus 3, 7, 3, 5, 5 plus 6, 12, 5. Then iron and friction loss plus, but iron and friction loss for each machine is 12, 6, 2, 5 times money 100. Remember, it's a percentage, it's a difference. How many percent?
Eighty-six
86, comma
289.
289%.